Hello everyone, hopefully all be doing well. Welcome back with another video on concepts with Arish. Today we are gonna discuss that what kind of questions comes in the past paper regarding the logic expressions. So first of all, over here we have got 5 different type of questions that normally comes in the paper. We will discuss them one by one. So starting with the from a circuit build a truth table. Okay, so sometimes they give you a circuit and they want you to make a truth table out of it. Okay, over here you have to understand build a truth table from the following circuit. So they have given you a truth table. No, they have given you a circuit and then you have to make a truth table out of it. Okay, so the circuit is given in such a way there's like a one symbol over here, one symbol over here, another over here, and another over here. So first of all, you have to understand, you have to identify what kind of symbols these are. So if you are not familiar with the symbols or if you're in confusion, I have another video. I have shared the link on the top. You can watch that and you can learn what kind of symbols are there and what they do normally. Okay, so over here we have got this is called as NOR gate. Okay, and you can identify it by seeing the fish shape over here, and there's like a dot at the end. Dot represent the NOT and the fish shape represent the OR gate, so that will become a NOR gate over here. Okay, so A and B are getting NOR together. Okay, and there's like this D symbol is very simple, it's called as AND gate. Okay, so this is the AND gate, and this again symbol fish shape symbol that simply goes with the OR gate. Okay, so and then C and the B are getting, so C and B are getting the AND over here. A and B are getting NOR together. And for the OR gate, you can see that like the one output is coming out of this and one output is coming out of this. I will call that at like a D, and I'll let me call this one as E. So D and E are getting OR together, D or E. And then you can see over here, this is another output coming out of here. I will call this as like a F. This F over here and this C from here are getting XOR together. Okay, it's called as exclusive OR. Okay, so you have to remember this, and again, if you do not know what the symbols do represent and what they do, then watch another video of mine and then you will learn how what they are. Okay, so first of all, you have to identify the possible combinations of the input that we are already done with, or work out the solution for the intermediate outputs, like layer by layer, you step by step. The same thing that we did, we identified like what this layer is doing, what this layer is doing, what this layer is doing, and how what this layer is doing, and what that's how we can get the final answer. Okay, and using the intermediate output construct, and then we go with the final output. Okay, so starting we have to make truth table. So again, we learned in the previous video that if there are like 3 combinations, then you have to go with like A, B, and C. So 2 raised to the power 3 will give you as 8 combinations in total. So there are 8 combinations. So first of all, 4 zeros, 4 ones, 2 zeros, 2 1, 2 zeros, 2 1, and then 0 1 0 1 0 1, and let's like the symbol. Okay, so now you have to go with, okay, they have named it as like P, Q, and R. So for the P, you have to understand it first. It simply goes with like A and B, and they are going NOR together. Okay, first of all OR, and then you are getting NOR together. Okay, let me show you over here what happened over here. 0 and 0 for OR will give you, if any of the one becomes, if any of the one input is a 1, then it gives you a 1 as an output. Okay, and so over here I will write the OR for these ones. It's not written over here, just in order to clarify to you. Okay, so you can understand it better. Let me write it down over here. Okay, so I'm getting it over here like this. So sorry. Okay, now 0 and 0 will give you a 0, 0 and 0 will give you a 0, 0 and 1, because it's one of them is 1, then it will give you a 1, then 1 again, 1 again, 1 again, 1 again, 1 again. So that's how you get all the outputs. But now as you have to do the NOT of that they have done it and they have given you a final answer. Okay, so this 0 will become 1, this 0 will become 1, and rest all of the ones will become all of the zeros. So that's the output that we will get for the P. Okay, in the same way we can continue it and we can go with the other one, that was B and C. They were getting AND together. So we know that what happens in AND is basically both of the inputs have to be 1 in order to produce an output of a 1. So only this one, both of them are 1, and both of them are 1. That's why all of them, rest of them are zeros. Okay, and only these of the 2 outputs are 1. Now going on forward, now they are combining these together. If I can show you at the backward over here, Yes, this was it. So now they are combining P and Q together in order to produce the R. So we can combine P and Q together and produce the R. They are going OR gate. Okay. Now you have again for the OR gate, if one of the input is one, then it will produce one as an output. So this one have got one, this one have got one, this one have got no one, so it will produce a zero. This one have got no one, it will produce a zero, zero, zero. So if any of them have got one, then it will produce a one. Otherwise, if none of them is one, then it will produce a zero. So that's the third part. Now they are combining. We are done with this P, we are done with this Q, we are done with the R. Now we have to take this C from here that's coming over here and this R in order to produce the X as a final result. Okay, so the output R and C, and it's an exclusive OR gate. Okay, exclusive OR simply what does it do? If you have any one of them, if both the inputs are similar, then it produces zero. If both the inputs are opposite to each other, okay, then it produces a one. So in this particular scenario, you can see this is 0 and 1, it will produce a 1. It will a 1 and 1, it will produce a 0. So 0, 0 will also produce a 0. This 1, 1 will also produce a 0. So if both the inputs are similar, then it will produce a 0. But if both the inputs are opposite to each other, then it will produce a 1. So that's a simple thing. That's how they all have gotten all the result. So as a final, we have seen that we can produce. So the total, we have done it step by step. Okay, so at the end we got the final result, and that's how this basic thing works. So the first thing we are done with is making truth table from the given circuit. That's one type of questions that normally come into the paper, and hopefully that will be understandable. Okay, so moving onward to the next one, that's called as from a circuit you have to build a logic expression. So before that, we were making using the truth table in order to from the circuit we were making the truth table. Now what we are doing, we have to from a circuit we have to build a logical expression. The same way they have given us a question, okay, in which the values are given. Okay, again you have to identify the basic symbols, what they do, how they do it. Okay, and then you have to write them down. Okay, so this is the gate 1, gate 2, and gate 3. Okay, so gate 1 is a simple, you can say A and B are getting OR. The fish shape represents the OR, so A and B are getting OR, and B and C are getting a AND. So then their outputs will be utilized, and they will give us an they will be used in order to produce the final result. That's gate 3, and gate 3 is being done with as a exclusive OR. Okay, the fish shape with the arrow before that as a yep, not arrow, like a bracket before that will produce, it's called as exclusive OR. Okay, so gate 1 is OR, gate 2 is and gate 3 is exclusive OR. You have to gate 1 and or exclusive OR gate 2. So if you can write it down, combine together, it will become something like this: A or B, like A or B, and then B and C, and then you have to combine them together and apply exclusive OR in the middle. Okay, so that's how this thing is done. Third type of question that normally comes in the paper are given as from a logical expression you have to build a circuit. Okay, so now again logical expression, you have to build a circuit. So they have given you a logic expression over here like this, and you have to make a circuit out of it. Okay, so first of all, what I will do, I will convert them into, break them into smaller parts. First of all, I have got A NAND C, then I have got not B or C, and then I have to combine part 1 and part 2 together in order to produce the exclusive OR. Okay, so first of all, A and NAND C. So as I see, I have got like 3 of the inputs, so I will consider A and then C, and I have to apply with NAND. NAND is like AND first, and there's like a not like circle at the end that will produce a NAND. So first of all, I will do that. Then they said that like the second part was B, not B or C. So first of all, it was not B, so I applied the not over here, and then you have to apply make it OR with a C. So you will take one input from the C and one input from the not B, and you can go it over here and make it a not B and OR C. Okay, now you have to combine both of the outputs together, and you have to produce a exclusive OR. So I take one output from here, one output from here, and I will produce a exclusive OR over here, and that will give us the final result. And now if you have to have got like anything that you have to do further. Okay, so over here they're saying now let's build a truth table from this. That's the same thing that we did in the first question, first type. Okay, from a circuit you have to make a truth table. That's really easy. You can pause the video over here and you can try it for yourself, and then you can see it further when I will do it. Okay, again, the simple steps are identify the possible combinations. Okay, so possible combinations are already there. Okay, then you have to do it layer by layer, and then you have to get the final result. Okay, so first of all, we have got like this one is like a P. Okay, and this one is like a Q, and this one is like a R. Okay, so what I will do is first of all, I have to produce a P. B not is like a P is considered as P, so you will take B and you will take P and you will just flip it down, flip it all the values, and that's how you'll get a not. Okay, then A and NAND C actually. Okay, you have to take an A and input from A, input from C, and then you have to apply NAND over there. So over here we have got the final result as out. Let me show you how it's done. A and first of all, you will go with A and C. Okay, so 0 0, you have to get both of the outputs as 1 in order to produce a 1. Otherwise, it will always produce a 0. If any one of the input is 1, it will not produce a 1, it will always produce a 0. Okay, so over here, this one will become 0, this one will become a 1, 0 will become 0, 0, 0, 0, and because both of them are 1, that's why it will produce a 1 and then 0 and then 1. Now you can see that like if it's like this, now you because it's also a NAND, not is also applied. So as a final in the queue, they have applied the not. So you will flip it down, all these zeros will become 1, and these ones will become zeros, and that's how you will produce it. Okay, hopefully that makes sense. And now you have to go with the third one, that was simply P or C. Okay, so as a for last part, okay, it was like P or C, you have to apply or means simply if one of the input is 1, it will produce a 1. So with in any of them, like if there's like one none of them is 1 over here, so that's why it producing a 0 over here, otherwise it will always produce a 1. So that's how it will go on. And now as a final result, you have to apply the Q and the R from the circuit, and then you have to apply the exclusive OR. You will apply exclusive OR. Exclusive OR is really simple, never get confused in that. If both the inputs are similar to each other, then they will produce a 0. If both the inputs are different from each other, in this scenario, in this scenario, in this scenario, and in this scenario, then they will produce 1, otherwise they will always produce a 0. Okay, if they are similar, they will produce a 0. If they are opposite to each other, then they will produce a 1. Now, yeah, that was the final answer, and you can look over here and you can practice it as well. Now, we will solve possible questions in the next video, but right now we're gonna go with the rest of the type of the questions. Okay, so for next one, we have got a from a truth table, build a logic expression and a circuit. From a truth table, you have to build a logic expression and a circuit as well. So that's one of the most watched problem, most concerning problem among the students. They don't know how to do it. Okay, so let me start again from here. From a truth table, build a logic expression and a circuit. That's the one of the most confusing topic to the students. So I can guarantee you, if you can watch it clearly, follow every single step, you can easily do it. It's not that confusing. It's just not being students normally don't learn it that carefully. That's why they get problems with that. Otherwise, it's not that much of a big deal. Okay. So first of all, what you have to do, you have to understand one thing over here. Always the expression is given like this. Okay, the truth table is given like this. So first thing you always have to do is to see which inputs are producing 1, which inputs are producing 1. It doesn't matter whichever the circuit, because we don't know what this circuit is, we don't know what the formula is, we are just given the table. So from the table we have to identify which inputs are producing 1. So combine each input with AND statement. Okay, first of all, you have to identify which one are producing 1. So you have to use an AND in the middle of that. Okay, and if the input value is 0, negated using NOT gate. Okay, so what they're telling us 3 things over here. You have to combine them using AND gate, and one is 1, and if something is using a 0, so I will write it as like A, and for the B it's a 0, it's taking a 0, so I will consider not B. Okay, so that's how we have to use it, utilize it. Okay, so over here A, okay, this way, and like it's always the fixed formula, you will use and then you will always negate the 0 1, so it will become not B. You will combine them together, and that will give you the circuit of the table. So you already know that like A, okay, and you will apply and with a not B, so not B over here. That's how you can get a logic expression, and based on logic expression you can get a circuit. So we can start from backward. Basically we have a table. From the table we saw that like which output is producing 1. So whichever output produce the 1, we utilize that output and we combine its input together using an and if any of the value in the input was 0, we negated it and we combined them together using an and that's how we got the expression. And once we have gotten the expression, then we have already learned how we can make a like a circuit out of it. Okay, and in the same way we can practice this question, and you can pause the video over here and try to solve it on your own. Following the same steps. There's one extra step over here that I will explain over here as well. So first of all, there's like a and there's like a B is producing a 1 over here. So again, we will go with like A and B, and this one is also the next one is also A and A and B. Okay, so yeah, you can get that. Okay, so once you will get A and B. Okay, but one of them over here is 0, so you will negate it with the bar. It will show that, but for next one there's none of them is 0, so you don't have to do that. Okay, and but now there are two ones. Two of the outputs are 1. Okay, so you have to combine them together as well by using a OR statement. Okay, so let's see over here how it works out. Okay, so first of all, not A, because of this 0 it will become not A over here. Then there's like a N, always becomes N, and there's like a B, and then it's like a B. And then for the second one is A and B. Very simple. And as I have told you, you will combine the as many ones as you will get in the output, you will just combine them using an OR gate, and that's how you will get your final expression. Okay, and then from the expression you can easily make a logic from logic expression you can make a circuit out of it. Okay, you can see not A, so not A, and you did it and with the B, and then again A and B, very simple. So one over here from one over here, and then you will combine them together and apply the OR over here. So that's how you can do it. So for this one, as you can see, it's becoming more lengthier now. You have to identify all the ones and you have to do the same thing. Nothing is different. Now everything is similar. You just have to follow the same steps. It doesn't matter if it's like 4 inputs are given or like 8 inputs are given. You still have to go with the same thing. So you can just simply identify over here. Let me go with this one. This one is producing a 1, this one is producing a 1, this one is producing a 1, and this one is producing a 1. Okay, so it will simply become A and B and C, and for this one it will become, let me write it down, A and B and C. But for the A, you will put a bar on the top because it's a 0, so it will be, you have to make it a 1. In the same way, you will write all of them down. Okay, and it will look something like this. So same statement, nothing different. Okay, so first of all, first row it will go to not A and B and C. For the second one, you can see A is 1, B is 0, and C is 1. So for A is 1, it's like A and because B is 0, so not B and C. And for the third one, you can see A and B, and C is 0, so C will become not A and B and not C. Okay, for the fourth one, you can say A and B and C. So that's how you will get your final statement. And you can also, it's also equal to, okay, that's a tricky part that you have to remember over here, and it always works. Okay, it's like a not A and B and C, so they skip the not over here. Not part is gone from here. Okay, same way not B is over here, you can skip the not part over here. From not C over here, you can skip the not C part over here. And for the A and B and C, if none of them is not, then just simply completely leave it. Okay, you don't need the fourth one. It will still produce the same output. That's a really important part. So when you're doing OR, because there are like 3 inputs now in the logic circuit, in a circuit diagram, you can't take 3 inputs, you can take only 2 inputs. So for the combined together ones, you will just skip the not ones. Okay, and you will just consider the simple ones, and it will still produce the same output. And when none of them is not, then you simply completely skip it, and still it will produce, it will have no effect on the final result. Okay, so that's why we'll simplify it, and that becomes the equal part. And now it becomes easy as you have produced this. Okay, so B and C, so they're doing B and C, and A and C, and they're doing A and C, and they're A and B, and that's how we'll get the final result, and that will be equal to that. Okay, now you can see it does not have any effect on that, so you have to remember this trick. Let me repeat it again. You skip the not parts in the 3 inputs, only in the 3 inputs, not in 2 inputs. When you have got 3 inputs in there, skip the not part and completely skip the one that have got all the ends. Okay, and that's how you can get your final, and it will not have any effect on the output. Okay, so that's how you can get a final answer. Hopefully you understand this. From the last part is like questions from the book book. In the book there are also problem statement given, like about problem type stuff, and in the past paper also comes like this. So we have to understand that now. Okay. Now, this one is also one of the most important problematic things that students find, because they are not able to read the question, and even though if they are able to read it, still they are not able to understand what does it mean. And again, I have told you many times, if you are not familiar with the how the logic gate works, what the logic gates are, you don't know the symbols and anything like that, then go watch my previous video. Okay, I have mentioned clearly over there what kind of logic gates are there and how do they work. Okay, so if you can understand that, then this become questions becomes a lot easier for you. Okay, so in the paper you can see that like questions are given like this, and you might a lot of you have a lot of problem with these type of questions. Okay, so let's start with this one. Okay, so over here they say that like a water control system uses a switch, a two pressure sensor. Okay, so switch S1, output is on means 1, and output is off means 0. They have also mentioned it over here. Okay, and it's on when value pressure sensor 1 is greater than or equal to 3 or less than 3. Okay, and pressure sensor 2 is greater than or equal to 3 or less than 3. So they are saying create a logic circuit that produce an output x of 1. You have to produce 1, because again from the 1 we produce all the values. Okay, so switch S is on, switch S is on, switch S is on. Let me go, switch S is on in this one. Okay, so which means S is on. They have already given it as AND. Okay, so you will write S1, and they say either P1 is less than 3, either P1 is less than 3. Less than 3 is given as this, it's a 0. So I will write P1 with a bar on the top. We learned that previously, because if there's like it's like a 0, then you have to negate it. Or, and you have to do it, or it's already given, clearly given over here, or P2 is less than 3 but not both. Okay, and P2 is also less than 3, and P2 is less than 3, P2, sorry, P2 over here, and P2 less than 3, you can see it's also producing 0, so we will negate it as well, and that's the expression that you can make out of it. Okay, let me explain it once again in next part. Okay, understood the problem. In this problem we have 3 different types: switch, pressure sensor 1 and 2. Okay, so each input can be either 1 or 0. Okay, refer to the table according to the given condition. Okay, so first of all, simplify the problem statement. I simplified it. S1, like I told you, S1 is on. Okay, and not P1, because not P1 was because less than 3, less than 3 was 0, so you negated it, not P1, and XOR not P2. Over there I said that it was just simply a or, but over there said but not both. That is changing it to exclusive or. Okay, P1 is less than 3 or P2 is less than 3, but not both. Not both means condition both will become similar, so that will become produces a 0. So that's why they are using a exclusive or gate over here. Okay, so now they're again explaining it over here in the same way. Okay, so S1 is like S1 over here, and is AND over here directly as it is. Either P1 is less than, so not P1 because it was 0 according to the table, and but not both is pointing out towards the exclusive for, and not P2 is given over here in the same way. Okay, now you have made it. Once we are already done with that one, once you are able to make the expression, you can easily go with making a circuit diagram of that one. So S1 is like simple, and you need, in order to make the end of that, you need not P1 not P2, so they made a P1 P2, they made it not, and then they have to go with exclusive or, and then they take output from here, and then that's how they are getting the final result. Okay, so that's how it looks like in the final result, and hopefully that you are able to understand it. And if you again you have any questions, you can comment it down on the comments, and I will try to help you with that. Okay, so that's the end of the discussion, and that's the end of the topic, and hopefully you will be able to understand it. And let's continue with another topic in another video. Thank you very much.